Hello everybody, I'm here with a simple example of a 2D particle equilibrium problem. So two-dimensional particle equilibrium. And here what we're given is that the mass of this ball is equal to 20 kilograms, right? So given the mass of D to be 20 kilograms. Remember, that's the mass and not the weight. And we also know that the force that applied here horizontally is 100 newtons. So that's given. We want to find the largest dimension D. So find D, this distance here, this vertical distance, so that the force in cable AC is 0, such that force in cable AC is equal to 0. In other words, we can call that FAC equals 0. So what we have to do, obviously, is to draw a free body diagram, and that would be free body diagram of point A. Remember, the tension or force in AC is already gone, so this force, remember, is equal to 0. So I'm not going to even bother with that. So actually, let me do this. Let me draw the free body diagram right here for you. So I start with the weight of this, ball, which is 20 times 9.81. Remember, the weight is mass times gravity. So that becomes 196.2 newtons, right? So starting with the weight, vertically down, 196.2 newtons. Then we have this force, which is 100. And then the only other thing that left here is the tension in cable AB, force in cable AB. And remember, this angle, if I call this angle theta, this angle is not known because we don't know what D is, right? Once we find theta, then from theta we can find easily that distance D, right? So this is a really simple problem. We just have to balance forces in the x direction. So two equations we have for a 2D particle equilibrium. So sum of the forces in x equals 0 will give us what? Minus FAB cosine theta plus 100 equals 0, right? And then, so that's one equation with two unknowns. Then balance forces in the y direction. We have FAB sine theta minus 196.2 equals 0, right? Now, so I have FAB sine theta. Let me line this up so I can show you how we're going to do this problem. So take 196.2 to that side and do the same thing here. Say FAB cosine theta equal 100, right? Now, the best way, the most efficient way to solve this problem for theta, and we don't need to find actually the FAB, right? I mean, we can calculate FAB if you want, but we don't need to find it. So what we do is just divide these two equations. So you see this cancels, so we end up getting tangent theta equal 196.2 over 100, which is 1.962. If you do inverse tan, theta comes out to be about 63 degrees, almost 63, 62.99 in fact. Okay, so now what we're going to do is take a look at this picture here. I'll redraw it here for you so we know this is 2, right? And this run is what? The rise is what? 1.5 plus D. And this is theta. So tangent theta, again, is 1.5 plus D over 2. So you already know what tangent theta is. You don't even need the angle, actually. Tangent theta is 1.962. So we can go ahead and solve for D. And D comes out to be 2.42 meters. So in other words, if we have this height, which is 1.5 plus 2.42, which is 3.92, then this point A would be in equilibrium and it's not going to move. Okay, thanks for listening. As always, if you like my videos, please subscribe, and I will come up with new videos almost every week. Thanks again.